Let's move on to problem number 3. So for problem number 3, we have a velocity versus time graph for the car, and now we want to plot the position versus time for this object. Now the interesting thing is that this thing is moving backwards the whole time. A lot of people got confused and thought that this meant forward, so I just want to be clear. Not moving forward. What it's doing is, it is in fact slowing down, and it's going backwards. So if we describe the motion of this object, let's keep it simple. The way this object is moving is as follows. The object starts going backwards at a constant speed of 10 meters per second, and then slows down going forwards until it stops at 6 seconds and stays stopped for the rest of the trip, of the time. And just to kind of make sure this is legible, there we go, like that. All right, so that is kind of it for that particular part. Now let's go ahead and actually plot the position versus time. So what we want to do is we want to split this into a couple of pieces, and we need to count out to 8 seconds. So we got 2, 4, 6, and 8 seconds. Now I could make you worry about how the position gets labeled on this graph, but I'm not going to do that. What I am going to do though is we'll make the bottom here the axis, and what we'll say is that from 6 to 8 seconds we're stopped, and from 0 to 1 second we're actually moving down at a constant velocity, so that's a nice straight line. And then what we need to do is we need to actually slow down going backwards like this. So that part is a constant velocity. This should be a curve. This is more linear, and this is flat. And so that's basically the graph of this object versus its object's position versus time. Now we want to know, when is the object moving at its fastest? What we say basically is from 0 to 1 second, the speed is the greatest, which is 10 meters per second backwards. It is always less after that. And then finally, is the object changing direction? The answer is no. It is slowing down. It never moves forwards, always backwards. And that is a really important distinction that we need to make. And then we want to know the acceleration from 1 to 6 seconds. So the way we're going to get that is basically we're going to get the slope. So for part E, I'm just going to zoom down here. For part E, we want to get the acceleration from 1 to 6 seconds. So I'm here, then I go here. So here I am at 1 second and -10. Here I'm at 6 seconds and 0. So to go ahead and get the slope, the acceleration is going to be, going to be 0 minus -10 divided by 6 minus 1, and that's going to give us 2 meters per second squared. Finally, we want to know the displacement of the object over the whole time. So I'm just going to tell you, with this graph, I'd recommend getting the area. So this is going to be -10 times 1. I'm going to get the area of the triangle. So what I'll do is I'll do 1/2 base times height. So that's going to be 1/2 times the base, which goes from 1 to 6, which is 5, times the height, which is going to end up being a height of -10. And so when I add these two up, I'm going to actually end up getting -35 meters. That's one way of doing it. Now the second way of doing it is, let's split this into 2 parts. From 0 to 1, we have x is v0 t plus x naught, because we're not accelerating. So we're going to have -10 times 1 plus 0, which would be -10. And then from 1 to 5, we're going to end up getting, we could do, say, v squared equals v naught squared plus 2 times a times x minus x naught. And we end up getting 0 squared equals 10 squared, negative 10 squared, plus 2 times 2 times x minus 0, just reading numbers off the velocity graph. So I got negative 10 for my initial, 0 for my final. The total time that elapses is 5, but we don't need that in the problem. And then finally, when we solve this, we're going to end up getting that x is, x is negative 25 meters. So we get a total displacement of negative 35 meters. So either of those techniques, using the equation or getting the area, will work to solve this problem. So that's question number 3. In the next video, we'll move on to question number 4.